Hi, my name is Mr. Crone, and this is part of my conceptual physics series. And in this video, I'm going to look at the difference between the instantaneous value of a property and the average value of a property. Now, essentially, any property that could change, like say, for example, your speed or your weight or time, if it can be changed, then it can be measured in terms of the average value for that property, which is sort of the overall look at it, or the instantaneous value of a property, which is looking at a particular time. Now, if the property never changes, then the average and instantaneous would always be the same. So let's say, for example, that you looked at your weight each day. And each day you measured the value of the weight and you found that the instantaneous value of the weight was, what, say 200. And the next day it was 200. And the next day it was 200. And the next day it was 200. Well, the average of all that is going to be exactly 200. So in situations where a property never changes, the difference between average and instantaneous is pretty pointless. There's really no reason to think about it. But that's not very exciting. And obviously, we don't look at properties that don't change. Almost any property can change. And so let's look at what the difference between average and instantaneous is, and then we'll apply it specifically to motion, some of the things that we've already talked about. So the average tells us something sort of about the overall value of the property, but it does not tell us anything about what was happening at a particular time or at any point along which this measurement was being made. So while the average tells us something about the overall value, the instantaneous tries to take the other approach. Instead of looking at overall what happened, it says what happened at a particular instant in time, and hence the word instantaneous. So if I said my instantaneous weight, it would be my weight right now at this moment, not tomorrow morning, not 2 hours ago, but right now at this moment. If I wanted the average value, then I might weigh myself 10 or 15 times over the month, and then I'll just take the average of those. And while it doesn't tell me what my weight was at a specific time, it does kind of give me an overall picture of what was happening to my weight. Right now my weight might be one thing, but 2 weeks from now, my weight might be completely different. And when I look at the average might not really reveal what I want to know. So the difference between average and instantaneous is not a right and wrong sort of thing. It's not about whether one is better or worse than the other. They just simply measure in different ways. One is focused on the overall, while one of them is focused more on what is happening at a particular time. So in order to make this more concrete, let's take a look at specific examples. And again, we're going to look at motion so that you can sort of connect what we've already looked at so far. So let's look at the first example. It says that Julia runs through the park at a steady 4.5 meters per second for 15 seconds. So we can think about our instantaneous speeds. Our instantaneous speeds would be our initial speed and our final speed. And I left space in between those because between those, I would like to put in the average speed. So the average speed is a V with the little bar, not an arrow, a little bar across the top. That little bar on top of any property means the average value of that. If you don't see that bar above it, it means it's asking for the instantaneous value. So when I say the initial speed and I say the final speed, those are instantaneous values, but this one in the middle is going to be my average value. Now this said Julia ran through the park at a steady 4.5 meters per second. So that means at the beginning of the motion, she was traveling at 4.5 meters per second, and at the end, she was traveling at 4.5 meters per second. Now we can calculate the average value, just like we could for any property, by simply adding together the final plus the initial and dividing by 2. So obviously in this case, all we're going to find is that 4.5 plus 4.5 divided by 2 is equal to 4.5 meters per second. We probably didn't need to calculate that, but in this case, this one, the value of the instantaneous and the value of the average were always the same because the property never changed, because Julia ran at a steady speed. So let's look at what happens when you allow things to change. So let's take a look at what happened when Duran was driving home. So in this case, we will have an initial speed, we will have a final speed, and we will also have the average speed. So this one says that Duran went from rest. That's like something you have to really pick up on because that means that he was not moving in the beginning, right? Even though that's not a number given to you, it is actually a number because to be at rest means that you have 0 speed. That doesn't matter whether you started with 0 or ended with 0. To say you are at rest means that you have no speed. So this one says from rest. That tells me that that was the initial. So he was moving at 0 meters per second in the beginning, and it said up to That word 2 would be a context clue that this was the final velocity, or speed, I should say. So the final speed is 20 meters per second. And now the question is, what is the average speed? Well, in this case, the average speed we can simply get by taking the average of these two numbers. So I would say V average is equal to V final plus V initial divided by 2. And in this case, that is 20 plus 0 divided by 2, which would give us an average of 10 meters per second. So I'll put that back over here. 10 meters per second, which should make sense because 10 is exactly in the middle between 0 and 20. And this method can only be used if you make the change from the initial to the final, either very smoothly, so it's continuously changing from 0 up to 20, or as long as you spend the same amount of time at each of the two speeds or other speeds that you spend at, that you travel at, then you would be able to just simply add them up and take the average of them. But I do want to point out, this method does not always work. This does not always work. The best way to get the average speed would be simply d divided by t. But in this case, we don't have the distance. Even though we have the time, we don't have the distance, so we can't get the average that way easily. So it is okay to add the 2 and divide by 2 as long as you make the transition smoothly from one speed to the next. So in this case, going from 0 to 20, the average would be 10 meters per second, which is exactly at the middle between these two speeds. Okay, so in this case, let's take a look at an example in which we have a different type of motion. The person is changing, but they spend a little bit of time at one speed, and then they change rapidly, and then they spend a different another speed for the same amount of time. So in this case, the initial speed is 1.5 meters per second, and the final speed is 3.5 meters per second. And this is the only other type of example in which we can add the two together and divide by 2 and expect that that would produce the correct answer. Even though I can always calculate an average, of course, I can always calculate the average of any two numbers, but will that give me the value of the correct average for this motion? Not always. Not always. It would only do it if we spend equal time at the two speeds or if we smoothly transition from one speed to the other. If the transition is made smoothly, then we can use this method. So in this case, it's 3.5 plus 1.5. That gives me a total of 5. Divided by 2 is 2.5 meters per second. Now, I would just point out that I don't think that's really necessary that we went to the equation here, because I think a better way of doing it would be to just simply visualize what is the middle ground between 1.5 and 3.5. If the average speed is between the starting speed and the ending speed, then all I need to do is to think about where is the middle of that number. So between 1.5 and 2.5, the exact midpoint, 2.5 meters per second. And this is an example where you would not need to show work in order to get full credit for this problem. Now, while verbally, we can see all kinds of examples in which I can get initial velocities, final velocities, or speeds, I should say, and also average speeds. The easiest way to see the average and instantaneous is to look at it on a graph. So let's just switch gears for just a moment. We'll take a quick peek at what this looks like in a graphical sense, and we'll kind of take care of these problems and see if we can identify the instantaneous and average at different values. Okay, so here we are looking at a velocity time graph. You can see that the velocity transitions smoothly from 3, because it says 3 right here. It says it shows the motion of a toy car that's speeding up from 3 centimeters per second to 45. So starting at 3, and then steadily speeding up faster and faster and faster, nice and uniformly, all the way up to 45 meters per second, 45 centimeters per second, I should say, at the end of 7 seconds. So let's take a look at some examples of just specific velocities or speeds that we want to get from this. So let's say that we want to know what was the instantaneous speed at the following times. Let's say 3 seconds. Well, that's a very easy question because all you're going to do is to read off the value of the graph. I would simply go to where 3 seconds is at. I would slide up along this line, and I can see that I'm just a little bit above the line, above where it says 20. So I would say that the speed at that point was most likely 21 centimeters per second. So the instantaneous value is just simply read off the graph, and therefore take a look. You can actually see all of the instantaneous velocities. You know, when we looked at the problem with Duran, we just saw the initial speed and we saw the final speed, but we didn't hear much about the speeds in between. This graph shows me everything in between the starting speed, which is right here. There's my initial speed, and there is my final speed right there at the very end. It shows me every speed in between. At any moment, I can tell you what was the speed. What about at 4.5 seconds? Well, at 4.5 seconds, I would want to come up here and I want to read off the value right there, which looks to be about 30 centimeters per second. Remember, if you don't put the little bar over the top of this, then you're assuming that you're meaning the instantaneous speed at some point. Otherwise, you would put the little bar to indicate that that was the average speed that you were talking about instead. So can we get the average speed for the whole motion? V average? Yeah, definitely we can do that because we can say V average is equal to the initial plus the final. Doesn't matter what order we add those in, and divide by 2. So in this case, that was an initial of 3 plus a final of 45 divided by 2. That means my average motion for this entire trip was 48 divided by 2, which is 24 meters per second. 24 meters per second is exactly the midpoint between 3 centimeters per second and 45 centimeters per second. So instantaneous speeds versus average speeds. Okay, they're not the same because the speed was changing all during the course of the motion. Okay, so besides looking at the velocity time graph this way, we could look at even more simplistic problems. What if we had a situation in which the speed didn't change at all? Well, this is pretty boring because obviously the instantaneous speed is 25, 25, 25, 25. It's always 25 because this person is not changing. So at a time of 2.5 seconds, how fast were they going? Well, they had a speed of 25 miles per hour. And if I calculated V average, that would also be 25 miles per hour because, of course, the starting was 25, the ending was 25. 25 plus 25 divided by 2 is 25. Probably not something that we even need to do with a graph like this because it's pretty clear that the average and the instantaneous are going to be the same because the motion is not changing. The property is not changing, and therefore the average and instantaneous are effectively the same thing. So that brings us to the end of average versus instantaneous. Hopefully that's made a little bit of sense to you, and I'll see you in the next video.